All right. The next two problems from our homework concerned polynomials. The first was to factor x cubed minus 1. In order to factor this polynomial, I want to try to find a linear factor, some root of this polynomial. Now this formula is pretty nice. If I want to solve x cubed minus 1 equals 0, why, I know that 1 cubed is equal to 1, so that should satisfy the formula, which means that x cubed minus 1 should have x minus 1 as a factor times some other term. And the question is, how do I find this? I would set up a long division where I am dividing the polynomial x cubed minus 1 by the polynomial x minus 1. I've gone ahead and left some extra space here for reasons that should make more sense as I work through the problem. In polynomial long division, I'm asking myself, well, first off, does the polynomial underneath the division symbol have a higher degree than the polynomial I'm dividing by? I say yes, so there's more work to do. Now, taking the largest exponent of x on the left, what do I need to multiply by to get the largest power of x over here? For the start of this problem, I need to say that x times x squared makes x cubed. So now I'm going to multiply my x squared onto x minus 1. I get x cubed minus x squared, and I need to subtract. X cubed take away x cubed is going to be 0, just like I picked. But now I'm taking minus negative x squared. That will give me a double negative. So I have a remainder of x squared minus 1. Again, I have a power of x. This is x squared. Compared to x to the first power, I keep going. What am I going to multiply by to make sure that I cancel in my next subtraction? I'm going to multiply by x. So this leaves me with x times x is x squared. Negative 1 times x is negative x. And we subtract again. Here's my 0. Again, I have a double negative. And I have this minus 1 coming along. Let's check this remainder again. This is x to the first power. This is also x to the first power. So I can multiply by a 1 and still get cancellation. 1 times x is x. 1 times minus 1 is minus 1. And when I subtract these, I get a remainder of exactly 0. That tells me that the other factor here is x squared plus x plus 1. Now, in a factoring problem, I want to continue to factor these until I get down to irreducible polynomials. But by using the quadratic formula, I can say, what would the roots of this x squared plus x plus 1 be? Why, they would be minus 1 plus or minus the square root of 1 minus 4 divided by 2. And once again, I'm left with this problem of the square root of a negative number. So my solution is going to be x cubed minus 1 is equal to x minus 1 times the polynomial x squared plus x plus 1. Let's look at the next problem, x plus 1 raised to the power 3. In order to solve this problem, I need to distribute my multiplication across a bunch of different sets of parentheses. So let me start up by only looking at the product of x plus 1 times x plus 1, and whatever that is, I'll need to multiply by another x plus 1 at a later step. So we're just focusing on this bit for right now. I can use the FOIL method to say, let's take the first two terms, that gives me an x squared. Let's take the outer two terms, that gives me plus an x. The inner two terms gives me another plus an x. And the last two terms give me plus 1. So altogether, x plus 1 squared is equal to the polynomial x squared plus 2x plus 1. The problem is asking me to cube this formula, though. So I need to take my answer from the previous step and multiply by an additional x plus 1. You may have seen something similar using a table where I can write the terms of one polynomial going horizontally, the other polynomial going vertically, and in each position here, I'm just going to multiply together the contents of the row and the column. X squared times x is x cubed. 2 times x times another x is 2x squared. 1 times x is x. And the multiplication by one row goes across similarly well. And now I ask myself, where are all of my x cubeds? There's only one of them. Where are all of my x squareds? Altogether, I have 1 plus 2, so I have 3x squareds. Where are my x's? I have 3 x's to the first power, and I have a constant of 1. So there is x plus 1 cubed.